Very quickly, to start with some rules and housekeeping, just if there is an emergency, where to go. So to exit on both sides, and you can go outside for this one and take some stairs down, and you will find a way. Actually, you're gonna not to panic, but you will find a way. So only one rule, actually, you're not allowed to eat in this room. So if you want to get some food, etc., you have to stay outside in the lobby here, or you can bring your drink, but not food. My name is Phil Moreau, and I'm a researcher at the AI Institute, and I'm also senior advisor in natural hazards for the Waikato Regional Council. I will be facilitating this workshop today, and I will have the heavy task to entertain for the day. Will be a big task. As you can see, no, it's me. But we've got the program, which is quite really full. So I'm sorry if we don't have time for French jokes. It's really a full agenda that we have today. And I think we should start very shortly because we are on time. Wonderful. So we are very good to go. And I would like to welcome Karin and Albert from the TAIAO project to give us a bit of what's going on the TAIAO project, and it's all yours. So you need a mic. If you want to stay here, there is a mic here that's working. Otherwise, we can provide a mobile one.
Hey, Tenakoto Kato, Wako Segrete Agua, Alberto Quinoa, Señora Tenakoto Katoa. Welcome everybody to this TAIAO workshop. So welcome to University of Waikato at Tauranga. So we are celebrating the 50 years of computing at University of Waikato. So we have this month, this August is the AI month of this celebration. So we are celebrating different events. So last weekend we celebrated the AI hackathon with AI Forum. That's something that was hosted by Phil and was a big success. And we think Phil will give us more details about that. Another event is we are celebrating this Indigi Data Aotearoa. This is like a school of 1 week that Maori students are doing at the campus of Hamilton. And we are also collaborating, and Nick Lim gave a tutorial on machine learning, and I gave a talk about the TAIAO project. So the TAIAO project is a project of 7 years. We are really half the project, so it's 3 years and a half. And this is a project with University of Auckland, University of Canterbury, Wellington University, Victoria University of Wellington, Becca, and Med Service. And if I need to say what is the most important thing of the project, this is the people. So I think the people is the key and is the reason why the project is being so successful. So as you can see, we have a team of environmental scientists, data scientists, software engineers. So that's what TAIAO is about. So we have this team of people working on environmental data science. So it means that we work on fundamental algorithms of machine learning, but then they are very, very applied to the environment, are very applied to environmental science. And one of the main goals is how we grow the capabilities. So how we really help to create the next generation of environmental data scientists. So one of the important things is the software, as you will see. This is something that we use. So this year, we have this new website. So this is something that we launched last November. So we have this new look of the website, the community platform. So the idea there is that people can go, look at data sets, look at notebooks, and discussions. So if we look at the website, we have these data sets. So we don't store the data. What we have is that we have information on how to access the different data sets. So you can see we have different categories, but all the data is accessible through the website. We have the notebooks. So the notebooks, the nice idea of these Jupyter notebooks in Python is that we have everything. We have the source code, we have the documentation, and we have the we have the results. So it's a good way to have everything together. And in terms of software, one of the main outcomes of the project is this River software. This is a software in Python. It's for doing machine learning on data streams. So that means that is real-time analytics. So we try to be very, very efficient. So we don't store the data. When new examples arrive, what we do is that we update the models. So this is very, very efficient. And then also we are dynamic. So if there are changes on the data, we are able to adapt. Another, I think, big project is this species identifier. So this is something that you can run from your mobile, from the website. So you can see it's quite nice in the sense you take a picture. This is built with the species of New Zealand. So this is really specific for New Zealand. And then we'll see what are the predictions. And then also we can see the explainability part. We can see, why the classifier is making this prediction. And this is also very useful to understand if something went wrong or if everything is all right. Another tool that we created this year is this tech. So this is a toolbox for evaluating AI explanation. As you know, there are now different methods for explainable AI. So the idea is, okay, so how we can evaluate them, so how we can see what is the best method. And then, the idea, again, is having a toolbox that, knowing the ground truth, is able to evaluate us. So this is also something that we hope is going to be very useful. And and then just to finalize, we are really into this idea of data mesh. So data mesh is a distributed data architecture. So you see that we have some case studies that use this data mesh architecture. So the idea is, okay, instead of centralizing everything in a data warehouse, data lake, or data lake house, what we are going to do is that we are going to consider data as a product, and then we are going to have this self-serving platform that is going to, with a federated governance, is going to be able to do data analytics, but in a more efficient way than the standard way of having everything centralized. So this is an idea that is quite new. It's from the last 4 years, but is becoming very used in many large organizations that they use a large volume of data. So it's not only for privacy issue, for data sovereignty issues, it's more for efficiency reasons. So I'll ask Karin to continue. Yes.
Tēnā koutou. Welcome everyone for another year. We're in the middle of our program. Really exciting moment for us. Oh, what happened to the slides? Oh, just a minute. Oh, yeah, thank you. And how do I, oh, yep. Oh, yeah. So it's been a busy year for the environment again. Last year I stood here and I talked about horrendous flooding, heat waves, all the problems that we're facing. And we didn't really realize at that point that that was minor compared to what was coming this year. So of course, this year started with horrendous floods up in Auckland, directly followed by Cyclone Gabriel hitting around the country, which we're still recovering from. The damage from that was extensive around the country. And there's still problems. Problems are expanding with invasive species. We have increased number of wallabies coming into New Zealand. We have invasive marine species that are featuring in the news. And finally, my last one is that we still struggle to keep our Kiwi populations up everywhere that we're getting them increased numbers, which is very exciting. We have equal cases where they're declining due to various issues. So there is never a lack of a well-trained environmental data scientists, you young people. And I think over the year, I've been talking again, both Albert and I and everyone in the program, continuously to people about what they need from data scientists. And I think the message is coming back over and over again is that we need people that are willing to co-design. Data for data's sake is not useful to anyone. We talk about ownership of data, provision of data, but it actually is not as valuable as we think unless people have the ability to make use of that data. And so the tools and advancing the tools is just as important as making that data and collecting excellent data, which is, of course, what TAIAO is about. So just quickly, Albert's already talked about the species identifier, which I understand is getting retrained all the time with all the new things coming on board. So it's getting better and better. The seagrass detection algorithm that went up on TAIAO last year is starting to get downloaded and used. Completely free. You can develop that into your own tool. We have work on more efficient streaming using energy consumption data. In explainability, we're looking at comparing a wide range of methods for which one is provides more explaining power. We have the fern wind detection algorithm, which is up on the platform as well, which looks at better methods for detecting fern winds, which are unusual wind events in dry valleys in Antarctica. Our forest flow work, I think, is beginning to come to a close, and that's on better understanding how water is used in forests, and that streams data into a central area. We have the marine heat wave prediction work still going on, which is getting better and better. And of course, the flood prediction in the Waikato project is showing some really excellent results. And finally, we started a program looking at underwater species identification using underwater footage. And this year we've been working with DOC to try and increase that capability using their data sets. Algal bloom detection group is still continuing on, making their algorithms more better. And so you'll hopefully hear more about all of these during the day, but I'm not going to badly introduce people. I'm going to let the researchers talk about their own work. So I hope you enjoy the day and welcome again.